Hey everybody, thanks for coming in today. I just wanted to let you know that we are going to start the presentation a little bit later. People seem to be having an issue jumping on, so give us about 2 more minutes and we will be ready for you.
Start with the intro though, right?
Yep, I am.
Okay. So
All right,
I will
everybody?
share, I'll share
Okay.
my screen and then we're ready to go. Okay.
Okay.
All right.
So hello everybody. I'm Martha Guerin and I'm one of the technical sales directors at Atmosera. I want to thanks for joining us for the AKS and Azure DevOps discussion today. We're excited that you're all here. Today we're joined by a partner at Microsoft, Brant Jones, the Director of App Innovation for State and Local Governments, and you'll be hearing from him shortly. I know there's a lot of old names that we've seen in the last couple of weeks, but I know there's a lot of new people, so I'm just going to do a quick intro to Atmosera. We are an Azure Expert Managed Services provider, the highest Azure accreditation a partner can achieve. There's only about 60 of us worldwide, so that's pretty exciting. Our consulting team works closely with Microsoft and aligns with a few of their core practice groups, including DevOps, app innovation, app modernization, infrastructure, data, and AI. And our training team also works closely with Microsoft and our consulting team to provide collaboration and knowledge transfer. So today's speaker, Ron Samita, is one of our top instructors and one of our go-tos for consulting as well. Through the partnership with Microsoft, Atmosera is eager to help the SLG community develop and enhance their AKS and DevOps skills. We're recording this session, so if you happen to have a colleague that wants to listen to it, or you happen to miss some of it, we'll happily send you the recording. And if you have any questions, please put them in the chat window. The last 30 minutes or so is going to be Q&A, but during the presentation, Brant will be answering questions, and Ron will also be answering questions. So if there's anything I can do, please let me know. Now I'm going to turn over the floor to Brant. Hopefully, here Brant is having some volume, some issues, but I'm going to guess that I'm actually going to hand it over to Ron, and then we're going to have Brant introduce himself in a little bit. So take it away, Ron.
Okay. So here is what I am planning to talk about for today. I am first going to cover, this is going to be largely about Azure and Kubernetes. So we're going to first look at some of the Azure services that are available, like the ACR, the Azure Container Registry. We'll look at how to create an instance after pushing up an image to the ACR. We'll look at creating an instance of it using the ACI, the Azure Container Instance. We'll then talk about the big one, which is the Azure Kubernetes Service, or AKS, and we'll look at some of the main configuration options that are available when you're using AKS. And then the second half of the talk, we'll be looking at Azure DevOps and how that can integrate with AKS. So specifically what I'm going to do, in fact, we're going to be building something from the ground up over the course of this talk. I'm going to start from a Node.js Hello World application. I will first locally containerize it and just run it as a Docker container. Then I'm going to actually take the image, push it up to the ACR, create an instance of it using the ACI, and then we'll deploy it out to Kubernetes, take that container and deploy it out to Kubernetes using AKS. And the second part of this, which is about DevOps, is where we'll take that AKS service. We will also take all of the files. It's not going to be a lot of files, but the 4 major files that are necessary for creating the image, and we'll put them up into a repo, for a GitHub repo, and we'll create a project in Azure DevOps where, and a pipeline, where we'll use that repo as the source. We'll run that pipeline, so it'll give me an opportunity to show you how to integrate AKS with DevOps. And then finally, this will be the culmination of everything, we will make a change to the source code and actually then see how the pipeline will automatically, after doing a commit in Git, will automatically cause everything in the build process to rerun and the redeployment to occur. and then we'll test that redeployment and see that the change that we make to the code actually has an effect when we run it. So that's the plan for this entire session, is to show you all these various Microsoft provided Azure facilities that support Kubernetes as well as DevOps, and show you that in the context of building something through the course of the entire talk. So let's start first with, in fact, before I even get into the details of the ACR, let me show you first what it is that I've already set up, and to give you an idea of where we're starting from. So right now I have an Azure Ubuntu VM that I configured. It has Docker installed in it. It's got Minikube installed on it. It's got kubectl installed on it. So all the major tools that you would normally use for building and testing containers and working with Kubernetes are already installed into this VM. And if you want to know some of the details of how to get to where I am now with this installation, you can look at the video of the past talks that I've given where I actually covered all of that. I also have, just so that you know where I'm starting from, a session created in Visual Studio Code where I'm able to access the files on this remote VM, because this is going to be critical. I'll be using this to make some modifications along the way. For example, that very last bit that I'm going to do where I modified the source code, I'm going to do it from Visual Studio Code, but this is connected through the remote SSH extension to this Ubuntu VM. And once again, if you want to know how to configure Visual Studio Code to use this remote SSH extension, which I have installed here, then watch my earlier video, again, a recorded video from an earlier session that I did where I show how to configure all of this to get to where I am right now. But the key to making this work is this remote SSH tool or extension that's available with Visual Studio Code. And it's an extension that comes directly from Microsoft. So this is not some random third-party thing out there. All right, so this is where we're starting from. I just want to show you the files. Since I'm going to be using this for all the demos throughout this entire session, I want to get you familiar with what is here. It's in this Node.js demo folder. And here's the JS code for the server itself. Pretty simple stuff. It's just a hello world Node.js server. It basically comes from, there's an actual sample on the Node site for Node and Docker, where I basically took the sample code and slightly modified it for what I needed to do. But it's basically that. So if you're familiar at all with Node and Express, you'll recognize this, where we notice, first of all, set a port constant for port 80, bring in Express, and we're taking any request that comes in and just returning back hello world. So not a really fancy demo. I wanted to make this, in terms of the code, as simple as possible, because really this code is not the point behind what I'm showing. I want to show the facilities of Docker, Kubernetes, and how Azure supports those facilities, right? So here's the last bit. We just call this listen, make this listen call, and then if this were running non-detached, we would write out to the console that we're running on whatever host and whatever port number, right? So this is the basic code for our hello world, just to get you familiar with that. And then here's the familiar other files that you would normally work with when you're working with Node and Express, a package.json file, and pretty standard stuff, right? Nothing really tricky there. And then I also did put in this Docker file, of course, which I'm going to need in order for me to Dockerize this hello world Node.js application. And looking at the major bits of this, just sets the appropriate working directory, does a copy of the package star.json files to the // and then just does a run of npm install. Of course, we're going to need to do that to get all the libraries installed that are necessary to run this, and the appropriate copy command. So then finally, this command right here, running this in order to fire up the server. And that's basically the main contents of the Docker file. One last file I'll just point out to you before I actually run this locally first is this .docker ignore, where since the node modules folder is huge and it's being generated automatically through the Docker file, there's no point in including it in the image itself. So we're specifying through the .docker ignore that we want to exclude the node modules directory and not put it into the image itself. And the same thing for the npm debug log files. We don't need those in the image either. So that's why those are part of the .docker ignore file. All right. So in order to, first of all, show you this in action, I'm going to just run a couple commands. We'll build a local Docker image. First of all, I'm showing you that I don't have anything in the way of Docker images other than the one for Minikube, in case we want to try testing out, like during the Q&A, some local Kubernetes bits, but I'm not really planning to do that in this talk. But just to show you, I'm starting pretty much from a blank slate here. And other than that, I've got those three files that I was just showing you a moment ago. And let's go ahead and build a Docker image so that you can see that this actually does do something. So I'm going to do a Docker build command, -t to tag it, and then node, I'll call this node demo, v1.0, and then dot for the local directory. Let's run that, build the image first, and then I'll go ahead and run it just to prove to you that what I showed you in terms of those files is actual running code and configuration bits. All right, so since I'm doing this from the ground up, you see that it does have to bring in the node image first. And since I never like to blindly sit here waiting on something to complete, I'm going to dive into the slides, because here's what we're going to do after I show you that I can get this running locally, is to use the ACR, the Azure Container Registry, which is a private container registry that supports Docker and the Open Container Initiative, or OCI. And the features of the ACR are geo-replication. There's an OCI artifact repository that supports Helm charts. And for those of you who are relatively new to Kubernetes, if you haven't had a chance to look at Helm, I would strongly suggest that you look at it. In the Docker Kubernetes course that I wrote and actively teach, I have a whole module on Helm, and it's something very cool that I encourage people to look at using, because it really does allow you to do one-touch deployment, and it makes things like rollouts, rollbacks very, very easy, much more so than what is already there in Kubernetes out of the box. There's automated builds and updates for containers, and there's integrated Azure Active Directory security through RBAC. So those are some of the ACR features. Let me see if this is finished yet. It has, so I just want to do one run of this. So first of all, I'll show you the Docker images that are there. I have node demo in my local image cache for Docker, tagged with version 1.0. And then I'm gonna now just go ahead and do one Docker run with the -d flag, so it runs detached -p. I'm going to specify local host, so 127.0.0.1 colon, and then I want to do a port mapping between port 80, which is what's being listened on within the container code that you saw in the server.js file, to port 8080 on my local machine, and I called this node demo version 1.0. So this is just a proof that those files work locally, and then we're going to make all this stuff work up in Azure. That's the next bit. But let me go ahead and run this. We will then just go ahead and test it by doing a curl to localhost. In fact, I don't even need the HTTP part. I can just do localhost 8080. If I hit localhost 8080, there's the hello world. So that Node.js application that I was just showing you a moment ago is now Dockerized, running on my local machine as I'm running on this local Ubuntu VM as I'm demoing. And I'll just do a Docker PS so that you can see that it really is there. There's the node demo. It really is up and running, and it is servicing requests to localhost on port 8080 because of this port mapping that we put in. So that's the first step, is I just wanted to show you how to take a Node.js simple application, first containerize it and run it locally. Next bit we're going to do, we're going to take that image that I just created and ran on the local Ubuntu VM, and we're going to put it up to the ACR. So the first step is I've got to create the ACR. So we'll do that going to the Azure portal, create a resource, and the place I want to go to is under the containers. Here, under the containers category, I'll find the ACR, the container registry resource that I want to create right there. And I'll specify first a brand new resource group that I'm going to call, I'll call this AKS demo-RG. One of my personal conventions, I like to put for resource group names the -RG suffix on the end, so that when I go back to delete all the stuff at the end of the talk, that I can easily identify what the resource groups are by the appropriate naming. So again, just personal convention that I tend to use, and you're seeing me use that in this demo. For the registry name, I'm going to call this ACR SLG demo. This has to be unique, remember, in all of Azure, because as with many Azure resources, if you see this in the lower right corner of the box you're filling in, indicating that it's an address, that indicates to you also that it's going to need to be unique in all of Azure. So I can't use a name like ACR demo because in all likelihood, somebody else has already taken that name. Somebody else has created an ACR resource. All right, in terms of the location, I am in Los Angeles right now, and I always tell people when in the Azure classes I teach to choose a geographic location that is, in the absence of any other information, closest possible to where you are. So I choose West US for this particular demo, and given where I'm physically located at the moment. And that is about all I really need for getting started with this ACR resource. I'll go back to the slides for a moment just to show you where I am. Now, there's a couple of things that you should be aware. In fact, before I get off this page, let me make you aware of this, the SKU. This SKU, showing you the options there, can be set to basic, standard, or premium. And here is a little bit of information about the differences between them. It's really a primary difference is one of capacity, and a secondary difference is one of whether there's geo-replication support. So standard is the default. That means it's 66.7 cents per day in terms of cost, 100 gig in terms of capacity for this resource. For basic, you only get 10 gig, but notice how much lower the cost is. So it's 16.7 cents per day. And for premium, it's $1.66.7 per day. And you get 500 gig, and you do have geo-replication support with a cost of, again, $1.66.7 per region. And if you want to see the details of the pricing, I linked the actual Microsoft Azure doc page for where you can see the details. And given that in some cases these values may change, then it's good to just be able to come to the actual page itself and see the details explicitly. But that's how you can look up that information. All right, let me go ahead and create the resource now. In fact, I'll just take the defaults everywhere else just to show you the basics of using the ACR. It did pass validation. I'll click create. And this will take a few seconds to, based on past experience, to get the ACR created. And then again, I don't like to blindly ever wait on anything, so I will tell you the next set of steps that I'm going to execute. I'm going to have to, number one, log into Azure by doing an AZ login command. And since I'm working through an Ubuntu VM, by the way, that means I will have to install the AZ tool first. It turns out I've already done that. In fact, I'll go ahead and do the AZ login step right now, since I can go ahead and do that independent of whether that ACR resource has been created. But I've already on my machine installed it. So at this point, all I have to do is just go to do exactly what they're telling me. Go to this web page here to log in, which I'll do right now. And I'll specify the actual code that they also tell me to put in, which is right here. And that will at least take care of the login part. If you were doing this totally from scratch with a brand new Ubuntu VM, you would have to use apt to install that AZ tool. But since I've already done that ahead of time, so I didn't have to waste a bunch of time running all the installation bits, that's why I already have it installed. I just run that AZ login command going in. All right, I'm gonna pick an account to log in with. And yes, I am trying to sign in. And now I should be good. It should come back to me at the command prompt in a second. You may now close this window. There we go. Little bit of a lag there before it responded at the command prompt, but we are now good. We are now logged in, which is what I wanted to have happen. All right, let me check the status. I'm going to be juggling a few things. In fact, throughout this demo, I'm going to be doing things in parallel because since in this talk, I'm going to be creating a bunch of different resources in Azure, some of which take a little while to create. That's why I'm going to actually spin them up to create them. And in the meantime, I'll go to the slides and talk about various concepts, so that way we optimize the use of our time. All right, let's go to the resource itself now. And you see that it's been created. The big thing I'm going to need to know is this login server name, which is the name that I assigned, ACR SLG demo, but then the next bit of it is .azurecr.io. And the reason I need to know that is when I log into the container registry, and I've already logged into Azure, but I'm going to need to log into the container registry. Actually, all I need there is the registry name. It's the next bit when I do the push of the image up to the ACR resource. That's where I'm going to need to know that full name that's shown there for the login server. But just to log into the registry now, all I have to do here is just AZ ACR login, and then specify the -- name flag, and then the registry name. In other words, just this part of it is all that's necessary for doing the initial login. So all I have to put here is -- name, then that value, that should log me into the ACR resource, and it does say that the login succeeded, so I'm good there. And then the next bit is we've already created the image, we've already tagged the image. So the thing is, though, I'm gonna have to rebuild it, but with the indication of the ACR login server, I'm gonna have to specify that when I do the build of the image. So in other words, I can't take the image that I just built a moment ago and ran locally. Here I'm gonna have to specify first the ACR login server, then /, and then the name of the image that I want to create. All right, so let's go ahead and do that command right now. Docker build -t, and then I'm going to copy this right out of the portal so I don't mistype it for the login server. Then / node demo, and again, it's got to be tagged. So I'm going to tag it with v1.0. In other words, you can't let that default to latest. In fact, in general, best practice is for you to actually tag your images explicitly the way I'm doing right here. Because if I just did it this way, then it's going to default to latest. And that can cause problems in a number of different areas. For example, if you're working with Minikube and you want to take a Docker image and then deploy it up to Kubernetes through Minikube, again, the image has to be tagged there, along with a few other things that you need to know about, which are beyond the scope of our discussion at the moment. All right, so I'm going to go ahead and build this image according to explicitly what's indicated there on the slide. So we'll do that. Oh, and one other thing, don't forget to put in the dot. You do have to indicate that the Docker file is in the local directory. And notice I'm in the same directory where the Docker file is, so that's why I need to put the dot there. All right. So let's go ahead and run that. Because the image is already there in my local cache, all it really had to do is just retag it. And then I'm going to just display, first of all, that the image is there. So no demo that I originally created, that image is there. This image here is there as well. So with the proper naming, so that's all there, and with the proper tag as well. So at this point, now I'm equipped to push the image up to the ACR. So the ACR, remember, is essentially just another repository, but up in Azure. And a reason to put things into the ACR, you'll see this when we get into working with the ACI and working with AKS, is that if it's up in the ACR, it's a whole lot easier for either one of the other two resources we're going to create after this to be able to access it. Okay? So I am going to have to, though, push my Docker image up to the ACR. And to do that, I'm going to run the docker push command, specify the ACR login server. That was that same value that I copied right out of the portal a moment ago, and then the actual name of the image itself. So let's do that right now. Docker push. I still have it in my clipboard, I believe I do. And then I'm going to specify / node demo 1.0, like that. Docker push. Let me just not exist locally. Node. Oh, no demo v:\v1.0. That's what I left off. There we are. All right. So now it's pushing this image up to the ACR. After this is done, if I want to be able to see that it's there from the command line, I can run this command, ACR repository list. And if you only have one image, this isn't really necessary to put -- output and then table. If you have a lot of images, though, it formats it a whole lot more nicely if you do put in this additional flag. And then, of course, you're going to have to indicate the registry name there, right? You can also see it once it's been pushed. You can see it up in the portal under the services repositories menu. But at this point, I've got to wait for this to finish pushing before I can show you any of that. It's almost done. There we go. So it's done. Let's go ahead and see it first from the command line. So I'll run ACR, the repository list command, and then specify -- name and the registry name, and then -- output and table, like that. And I can see that there is a node demo registry there. Since I mentioned a moment ago that you can see it in the portal as well, let's look here and verify the fact that we see it. If I go under services repositories, there is that node demo repository. It is there, and when I click on it, then you're actually able to see further information about this repository. and including the tag. And I'll just go click on that tag, just go one level further. And you're even able to see things like the schema manifest information. That is all visible there as well. Right? So that's a way for you to view it. There's a screenshot of what I was just showing you right there in the portal. All right, now, in order for this to be useful, I need to be able to run a container based on that, run a container instance based on that image that we just pushed up to the ACR. And I'm going to do that right now by executing the command you see on the screenshot there, which is similar to the command I ran a moment ago when I was testing this on the local machine, everything on the local machine. But now I'm going to actually get the image from the ACR. So here's what we got to run. Do a docker run -p. Again, I'm going to map the port to the local port of 9000. And remember, in the actual code itself for the Node.js code that we are, Hello World application that we are containerizing, it's listening on port 80. So I'm going to map to the local port 9000. And then I need to do a -d command. I'm going to specify, and it's still there on the clipboard. It is, that's good. Node demo :v 1.0. And then I'm going to just run it, basically. I think that command is what I want. Let's verify that. So it presumably now has created a new instance. Let's run docker ps to see that there's another instance running, and it's right there. And we should be able to test this out by just hitting localhost with curl. Local curl, if I could ever type it, localhost 9000. And you see that works perfectly well doing it this way. But instead of, note the significance of this, instead of working by a local image cache, I'm now actually able to run it from what I have up in the ACR. That is what you're seeing there. Okay, now, next step, let's look at another Azure resource, which is the ACI, the Azure Container Instance. This is an environment for running Docker containers that is managed, serverless, and it relieves the developer and admin from having to worry about managing the VM. It can run containers isolated, on demand, and without orchestration. And here are some of the usage scenarios for it. Now, I am going to be talking about AKS after I finish this discussion of the ACI, but in some cases, if a full AKS deployment is not necessary, then you can look to use the ACI as we're going to do here. This can also be used by AKS for elastic bursting if that is needed. So if you, in other words, get like a sudden spike and you want to be able to handle that, then the ACI can facilitate that in conjunction with AKS. And this is also used in data processing scenarios, or if you're writing a logic app and you want, or an Azure function perhaps, or you're using Azure queues where things can be event driven, then there is a connector, for example, with Azure Logic Apps to be able to connect to the ACI, so an Azure function. So this is all reasons why you might want to at least know that the ACI exists. While it isn't as fully featured as what you have in AKS, which is what I'll show you right after this, at least it would be good for you to have some knowledge of the fact that this is available, and it's yet another tool in your arsenal of things that you can work with in terms of containers and Azure. Okay, so let's go back to the Azure portal. I will create the next resource, which is the ACI. Again, I'm going to go to the containers category, and I'm going to create a container instance. Once again, I'm going to choose the same resource group I created a moment ago, AKS demo-RG. I'm going to put all the resources I create for this demo into that resource group. I'm going to call this ACI demo. Again, choosing West US. Note that this does not have to be unique in all of Azure, unlike what I had with the ACR. And then in terms of the image source, well, in fact, there's one thing, very important thing that I need to do before I can create this. Let me go back, actually. I need to go back to the ACR resource. Since I want to have the ACI pull the image from the ACR, there's one additional step that I need to do. So let me do this first, which is going back to the container registry that I created. I need to go to access keys and turn on this admin user bit within this access keys blade. Notice this is disabled by default. If I don't turn this on, if I don't enable it, which I'm going to do right now, right? Then the problem is when I create the ACI resource, as I was going to do a moment ago, then I will not be able to see a reference to the ACR resource that I created earlier. And since I want the two to be able to be linked to one another, that's why I have to remember to do that additional step. It's in the slides too, and we will make these slides available to you. So if you want to recreate everything that I'm doing here, then you'll be able to see that I have a screenshot in the slides. All right, let me go back to where I was. Set up the ACI resource with the resource group as AKS demo-RG. I want this to be called ACI demo. And in terms of the image source, this is why I did that additional step, because I want to choose Azure Container Registry. And notice how this is all available to me now. The registry is there in the dropdown, the earlier registry I created. The image that's there is also showing up as no demo v1.0, so that's all good. In fact, this is exactly what I want. I can just take the defaults from here on this blade. There's one additional thing though that I'm going to want to configure, and that's by going to the next tab under networking, and it's right here. Because I want to make this public, I want to be able to show this to you of how to expose what I'm creating publicly. I'm going to put in a DNS name label here. And again, this is all in the screenshots. So here's a screenshot of the steps that I'm going through. Number one, in fact, this really is something you need to do before you create the ACI, which is to, on your ACR, if you want to link the two up to one another, turn on this admin user bit, then create the container instance as I'm doing now. Make sure that not only have you selected the registry in the dropdown, but that you, when you click on networking, that you fill this in. And I'll fill it in just like what you have on the slide there with node container, right, for the DNS name label. Everything else, I'll just go ahead and take the defaults and click on review and create. And after it passes validation, we'll create the resource itself. And then the next bit is after the resource gets created, which is gonna, again, take a few seconds, then since I did on the previous blade here, specify the under networking a DNS name label, then I'll see an FQDN on the overview blade for the Azure Container Instance that I'm creating. And all I have to do then is hit that. And I should be able to see the end result of that hello world displayed in a browser. And since this is publicly available, then any of you should be able to hit that same address as well and be able to see the end result. All right, this will take a few more seconds to create. All right, since again, I never like to just blindly sit there waiting on something to create, I am gonna go and start talking at least about the next big thing that I want to discuss in this talk, which is AKS, the Azure Kubernetes Service. AKS is a hosted Kubernetes service that is serverless, managed, and this, again, relieves the developer and the admin from worrying so much about the operational tasks. And the advantages of using the AKS as opposed to using other tools to set up the cluster for you, for example, kubeadm in a real world scenario or minikube, is that the deployment process is simplified pretty significantly. You can configure the features that you desire. Once again, there's elastic provisioning support. And big thing that I'm going to be showing you at the end of this talk, integrated CI/CD. Right? And not only that, but a comprehensive set of security features are available with AKS as well. All right, resource has been created. Let's just prove that this works by going to that resource. Here's the FQDN that I was mentioning a moment ago. I'm just going to copy that. I will throw this up to a browser and hit it, and there you go. We have our hello world showing up there. So this is proving to you that I have, number one, taken an image that we started from, which is that hello world image. Number two, we created the ACR, we pushed that image up to the ACR. Number three, we created an ACI resource and we pointed it off to the ACR. And then finally, here's where we are in this demo up to this point. We looked up that FQDN and we are actually hitting it from a browser, and we are able to see that that server is up and running and publicly available, and that hello world is being shown back in the browser there. All right, so that's the ACI.
All you have is a white screen. Okay, good.
Are you close now? Okay,
Nope.
Cool. All right, so let's look at the big one next, which is the AKS resource. This is, just so you know, a little bit architecture. In fact, here's what I'm going to do, actually. I'm going to, because this will take the longest of all of these resources to create, I'm going to go ahead and quickly run through, start the process of having it be created. and then I'll go back around and I'll backfill the steps that I'm doing in the portal. This way we won't spend as much time sitting there waiting for the resource to create. Because once again, I've got this problem since I'm doing these demos in real time, and these resources are longer to create. That's why I just want to spin it all up. I'm going to quickly rush through the creation process, and then, like I said, while it's creating, I'll go back and explain the steps that I'm doing here. And this is just for efficiency of optimizing our time in terms of this talk. All right, once again, I'm going to set the resource group AKS demo-RG. I'm going to just take the defaults here for the cluster name. I'm going to call this AKS demo. And let me see what else I need here. I'm going to take all the defaults there. In fact, I'll take all the defaults here all the way around. And I will take every default, as a matter of fact. And again, I'm going to go back and explain some of these various options. But there's one thing that I'm going to set to a non-default value. And that is here, the container registry. I'm going to pull this down and select that ACR SLG demo ACR resource that I created at the beginning of this talk, right? Very important thing I want to point you to: if you are creating an AKS resource, as I am doing now, and you do want it to be linked up to your ACR that you might have already created, then I would highly recommend that when you create the AKS resource, that you configure it to point off to the ACR rather than trying to do it after the fact. If you're wondering, it is possible to do it after the fact, but you have to do it from the command line, and it's kind of complicated. So the best bet is to remember, when you're creating the AKS resource, if you want to work in conjunction with your ACR, then make sure you go to this blade on integrations, that you pull down the drop down there, you specify the appropriate ACR, and now I'm going to start the process of creating this. All right, and while it creates, like I said, then I'll go through the details of what some of those default settings were and which ones you might want to change from the defaults. I didn't change them in this demo for simplicity, but in real world scenarios, it's very likely two things. One, that you'll want to change various settings from the default. And number two, that you might well want to do this with an ARM template rather than doing it, or from the command line rather than doing it through the portal. I'll get into the details of why I say that coming up in a moment. While this spins up and is being created, which, like I said, is going to take a minute or two, let me go back to the Azure portal, act as if I'm going to create a new one. And that way I can talk about some of those options that I quickly glossed over in the interest of just getting something created and getting the creation process going. All right, so we're just gonna, I'm not actually gonna create a second one. I'm gonna act like I'm creating a brand new one. Here we go. All right, and then now I can sync back up to the slides and talk a little bit about the architecture of AKS and also what other options I might suggest that you might want to change. All right, so the AKS architecture is built on the AKS engine, which is the Azure Kubernetes Service Engine. That engine is open source. So if you want to actually see the source code for it, you can by going to this GitHub site. So I'll just click that link for a moment just to show you that, yes, it is open source. Yes, there is a GitHub page for it, and this is that page. All right, so that's one of the first things that you might want to know about in terms of the architecture. This provisions the Kubernetes cluster, and it uses ARM templates. And the control plane now part is going to be managed by Azure. It makes the orchestration and the services available to your application workloads. The nodes, on the other hand, are managed by the user. One of the important things to know about when you work with AKS is which parts are they managing for you and which parts do you have to worry about managing yourself. And so the node parts, that's the part that's managed by the user. And of course, that runs your application workloads. This is a critical architectural diagram that comes from this documentation page. So once again, I like to always give attribution to where I'm getting these diagrams from. It comes from this Kubernetes core concepts for AKS stock page. If you scroll down a little further in the stock page, you'll see the cluster architecture diagram. And I just copied that, put it on the slide. But if you want to read more details about it, go to that doc page. But the important parts that I want to make you aware of for this architectural picture are that division between what is Azure managed and what you need to manage. And the Azure managed part is the control plane. So that includes the API server, the scheduler, etcd, which is your backing store, and then the controller manager. The part that's customer managed would be your kubelet, the container runtime, the containers themselves, the kube proxy. This part is the customer managed part, and all of these things would of course be part of the node. So more generally, the customer managed part of the nodes, the Azure managed part is the control plane when you're working with AKS. So the control plane is created automatically when the AKS cluster is created. It resides only in the region where the cluster itself is created. And it's not directly accessible, it's abstracted from the user. But the good news is there's no cost to the user, right? No additional cost to the user. It's accessed indirectly through either the CLI or the portal, and you use the AKS engine if direct access to the control plane is required. If for some reason you did need direct access, then you can use AKS engine. The control plane is single tenant, and it communicates with the nodes. The configuration and security are all provided by Azure. Right? Now, one of the big decisions that you need to make when you first set up your AKS resource, and again, I just took the defaults, but the cluster preset that you want to use. So I'm going to go back to the portal here for a moment and just show you some of the options that are available here, right there. All right. So for the cluster presets, this section, let me go back up to here. Yeah, here's the region part. Of course, notice that you can specify the availability zones, which defaults to a value of 1, 2, 3, but you can turn off various ones of those options for availability zones. For the Kubernetes version, here's something I should point out to you with the Kubernetes versioning. It defaults to 1.22.11. That is not the latest version. What I've seen with AKS in general is that they lag a little bit behind what the very latest versions of Kubernetes that are currently available are. And if you really want to, though, you can ratchet this up to a newer version, and you can go all the way up to the 1.24 preview version. In general, though, I would suggest for production scenarios that you not use, for example, preview versions. In fact, in general, I don't like to use preview versions of anything for production scenarios. So I would suggest the highest version you might want to choose here is 1.23.8, but the default 1.22.11 would be a sensible choice, which is why that is selected right out of the box in the Azure portal. All right. API server availability, notice the default setting there, 99.95% is what's chosen. If you want to optimize more for cost, though, and you're willing to give up a little bit of API server availability, you can ratchet that down to 99.5%. Right. Now, looking at the primary node pool, this is where you get into the node size issues and the scaling method, whether you want manual or auto scaling, and the node count range. Now, for node size, let me talk a little bit about that, because this is one of those values. I mentioned that there's some values here that you are very likely going to want to change. This is one of them. Depending upon what you are working on, if you want to be able to, for example, run machine learning simulations, perhaps, then you'll almost certainly want to ratchet this up to a larger VM size than what is specified here. So if you want to know the details about the default selection, which is DS2v2, you can click on that little link in the portal there, where it will take you to this blade for select a VM size, and then you can look to see, number one, the details of the VM size that's selected by default in terms of the number of vCPUs, the RAM, the data disks, and so on. Or if you decide that is not good enough for your needs, you can ratchet that up to a higher level by selecting one of these other options here. Now, one of the things I should make you aware of, though, is if you are running stuff that's very computation intensive, there are some of these options where you're not going to be able to just blindly go into the portal like we're doing now and select a more powerful VM size and immediately be able to start working with that, because there are quotas. There are quotas for your subscription where certain VM sizes are just not available immediately, where you literally have to go and make a request in to be able to use or to up your quota for using a larger VM size. Right. So I just want to caution you about that, because I ran into this with some consulting for Kubernetes and AKS that I did, where the client was needing to deploy RStudio out to AKS. And this is in conjunction with doing machine learning. And with machine learning, because it is so computation intensive, they wanted a much larger VM size. I was not able to, when I configured AKS for them, just come in here and immediately select the VM size they wanted and be off and running with it. We literally had to put in a request to up with their subscription the quota for being able to use a larger VM size. And when they actually went into production with this, they wanted a VM size that was large enough to where I couldn't even just go into the portal and up the quota. We had to actually make a formal request to Microsoft, which takes at least a day before it gets approved. And this is a safety measure. In case you're wondering why this is the way it is, it's a safety measure, because if you were able to just blindly come into here, select whichever one you wanted that sounded good, and immediately start using that VM size, the danger is the cost could be astronomical, right? And you might not even realize the cost is as high as it is. So this is where you have to actually make a concerted effort for those VM sizes that are really huge to be able to request them. There are different levels, right? There's the level of just go into your subscription right in the portal, say you want to up the quota, and depending on the size of the VM, that might happen right away after you up the quota, and then you're able to use it. Or it might be where you literally have to put in a request to Microsoft in order to be able to use that larger VM size. All right, so that's what this is referring to with the node size. There is scaling available, either manually or auto scaling. Manual scaling would imply where you put in a particular node count value. Auto scaling is what I would recommend, and for most scenarios, and it's recommended here in the portal as well. And it's recommended for the standard configuration in particular. And you can specify the node count range. So note the node count range is between 1 and 5 by default, but you can certainly up that value, right? Again, though, subject to the quota, depending on the node size you're selecting. All right, going to the node pools blade next to give you an idea of what's here. There's already a node pool that is there out of the box, but you can add additional node pools if you would like. So by clicking on this add node pool, you can indicate the node pool name, the mode, whether it's user system node pool, whether you want to use a Linux or a Windows node pool, also availability zones. And again, you can specify the scale method just like what is there for the node pool that you get right out of the box. All right, so that is what that piece is. And then you can also specify whether you want to enable virtual nodes. And note the node pool OS disk encryption is set to encryption at rest with a platform managed key. You can change that to encryption at rest with a customer managed key if you have a key of your own. But either way, note that the encryption type for the node pool OS disk encryption is going to be encryption at rest, which is a good thing. In general, that is what you want. All right, looking at the next piece, which is the part for the access for authentication and authorization. By default, they choose local accounts with Kubernetes RBAC. Note there are a couple of other options available here. Azure AD authentication with Kubernetes RBAC, Azure AD authentication with Azure RBAC. So there are a couple of other options available depending on how you want to configure your authentication and authorization. You might want to investigate whether you want to stay with this default, or if you do have Azure AD accounts and you want to make that work in conjunction with your AKS resource, that's where you may look to change the value from the default here. All right, this is a big one, this networking one. When I did that AKS consulting project I was mentioning a moment ago, this is the one that pretty much forced me, this networking configuration settings, that forced me into not configuring the resource through the portal, but into either doing it from the command line or through an ARM template. One of the things you need to be aware of is that there is a ton of potential configuration settings with AKS resources. Right? Not all of the possible configuration settings are visible in the portal. Some of the configuration settings and some of the settings that you're going to need for real world scenarios are going to need to be done through either command line or ARM template. If you just have a pretty basic setup like what I'm doing in this demo, this is why I didn't modify any of these networking blade settings, then you'll be fine. You can do it all from the portal. But in real world scenarios, especially production level scenarios where you're doing intensive computing and you have very stringent security requirements, it's very likely that you are going to need to access settings that are not explicitly shown here in the portal. But let me quickly go through these in particular, because like I said, this was the biggest sticking point that I encountered when I had to do this for a real world deployment. All right, there are two major options for the network configuration: KubeNet and Azure CNI. And Azure CNI is a networking plugin that's explained here that allows clusters to use new or existing VNet with customizable addresses. So if you did care about having customizable addresses, you did want to use a new or existing virtual network, then Azure CNI would be the choice. If you just want to take the default values, you want to make the configuration simple, then you can use KubeNet. KubeNet is a networking plugin that creates a new VNet for your cluster using just the straight up default values. All right. So that is the first important choice that you need to make when you create this AKS resource, is that choice between KubeNet and Azure CNI. Now, I'm getting ahead of the slides, by the way. Here's some more detail about the cluster presets, right, and the options that are available there. This is the blade I was showing you a moment ago. Here's the bit I was talking about with the nodes, that at least one node is required. Runs the node components and container runtime, and then this is implemented under the covers as an Azure VM. And you saw in the settings for the node pool that you can either use Ubuntu Linux or Windows Server 2019. It's automatically created based on the number of nodes that are requested when the cluster is created, and it can scale out based on demand. And you saw how you can specify a range for the node sizes there. And the billing for the agent nodes is the same as a standard VM. So there's no special billing that occurs for VMs used here. It's just the same as it would be if you were creating, like, for example, an Ubuntu VM like I was doing in that demo a moment ago. All right, the node pools group together nodes with the same configuration. There's a default node pool with at least one node pool per cluster. The number and size is specified upon cluster creation. It's composed of a set of VMs that run the agent nodes, and the node pool is used by the cluster for scaling and upgrading. All right, here's the node size families. I was just going over this. You need to select the appropriate node size family based on your requirements, whether you want to optimize for compute, memory, storage, GPU, or high performance computation. And by the way, if you want to know more about this, more than what's shown on that one blade that I was talking about, you can go to this doc page, which has the sizes for the VMs and more detail about them. All right. Give me 1 second. I'm going to just open up my window here. It's getting very hot in the room I'm in. Okay. So here's the screenshot of creating the AKS cluster, configuring the node pools. We went over that a moment ago. The main part I want to get to is that networking part, because I want to sync it up to the slides. But let me just cover the bits that I just went over in the portal. For authentication and cluster infrastructure, saw some of these things. The identity is required to create the resources, for example, load balancer or ACR. There's a service principal that's manually created. It's complex to manage, and it must be renewed to keep the cluster running. And there's a system assigned managed identity that's a wrapper around the service principal that simplifies management, and it's automatically renewed every 46 days by default. Right? You saw that this choice in that pull down a moment ago, either using RBAC or using AKS managed Azure Active Directory. RBAC, role-based access control, is where it assigns users and groups just the needed access, the scope and permissions to the scopes and permissions to the namespace of the cluster. And the AKS managed AAD, this leverages Azure AD for managing the users and passwords. So the choice between these two would largely be based on if you have an Azure Active Directory set up and you want to leverage that with AKS, then it would make sense for you to choose something other than that default drop-down selection, right? And this is that part about configuring the authentication. All right, this is what I wanted to really get into right now. I want to get into the details that are on the slide, because this is, like I said, one of the areas from my personal experience with this where you may well want to change from this default. The most likely place, one of the most likely places I would say, in addition to the node size, would be on this blade right here for networking. The selection between KubeNet and Azure CNI. So the KubeNet setting is the default one. The nodes are assigned routable IP addresses, and the pods use network address translation to reach the resources external to the cluster. The benefit of using KubeNet is it conserves IP addresses, and there's a limit of a maximum of 400 nodes per cluster. Azure CNI, with that selection, which you have to go out of your way, this is not the default, you have to go out of your way to select that. With this, the pods get the IP addresses from the subnet, and they're directly reachable from connected networks. But one of the big issues that you have to be careful with in using the Azure CNI is the potential for IP address exhaustion. So this is going to require you to manage very carefully your IP addresses, or not necessarily you, but your admin at least. If you're an admin, then you're going to be worrying about this for figuring out how you're going to divide up your IP addresses appropriately, right? For the host part and for the subnet part. And because this requires a lot more management, using Azure CNI is a lot more challenging than using KubeNet. And this is the reason why KubeNet selected as the default, because it's going to just basically give you a set of default values. You don't have to worry about IP address exhaustion in the same way that you would have to worry about it with Azure CNI, but it's less flexible, right? Anytime you're taking defaults, of course, it's going to be less flexible. Here's a screenshot of the blade we're on for the selection between KubeNet and Azure CNI. And now here's another very important part of this blade that I want to go over as well, which is enable private cluster. Very important security issue. In real world scenarios, you're going out there and deploying an AKS resource. It is very, very likely you're going to want to turn that on, enable private cluster. You will, if security is important to you in your deployment, you will probably not want to have people who are able to, from the outside, get into that private cluster unless they're part of your virtual network configuration. And that's why it's very likely you're going to want to turn on enable private cluster there. Once you get into turning on enable private cluster, that takes you into a whole nother world, which is part of what I was alluding to a moment ago with how complex this can become, and the fact that you may not be able to configure all of this in the portal. Because some of the private cluster settings, in fact, let me take you to a couple of web pages that I think you should be aware of. I'm going to search for this in Chrome that relate to all of this. All right, so private cluster, in fact, right there, I have it in my history, private DNS zone AKS. All right, this, and when I had to configure this for the consulting that I was doing, creating a private cluster with AKS. So first thing, right, you probably will want to make your AKS cluster private for security reasons in real world production scenarios. And given that, then you're into a whole nother group of settings that are much more advanced networking type settings here. Things like whether you want to disable a public FQDN, right, fully qualified domain name, and also the configuration of the private DNS zone. This is the one setting that forced me into using an ARM template as opposed to being able to create everything right here in the portal, because this setting is not available in the portal. You see, there's no drop down for the for which private DNS zone setting that you need to look at using. All right, I'm going to point you to also to another website. So not only this is the documentation page, but, and this is a whole nother topic unto itself, by the way. But I do want to, in fact, let me go back from here, since I just had it in this search. There's a really good website that explains the private DNS zone settings right over here. Configuring a custom private DNS zone. This is basically what I had to look to do. Was this one? No, that's not the right page. Let me get to the right one. It was this one. I think it was this one. Let's see. No. There's an entire, in fact, there's an entire video, but I'm just looking for the particular one. Not that one. That one. That's the one I'm looking for, right there. This has a very good explanation of the DNS options for a private Azure AKS service, and he does a very good job of explaining the three major options for the private DNS zone system, which is the default option, where AKS creates a private DNS zone in the node resource group. Any virtual network that is linked to the private DNS zone can resolve the name. None, which defaults to the public DNS, where AKS creates a name for your cluster in a public DNS zone that resolves to a private IP address, or a custom private DNS zone where AKS uses a private DNS zone that you or another team has created beforehand, right? Like I said, this gets very, very complicated, but it's something that if you are going to go to all the trouble of creating a private cluster, you're probably going to want to go to the trouble of looking into the various options that are available here and configuring the appropriate one that exactly meets your needs in terms of convenience and security. By the way, none by far is the easiest to use, right? and requires the least setup. But if you do have a very customized or very specialized scenario, then you may want to look to use one of those other two options. But again, in order for you to select at a fine grain which option you want, there's just not there in the portal. All right. Last bit of this, and then I'm going to carry on with the rest of this demo, which is, like I said, under this blade, integrations, container registry. Make sure you select the appropriate container registry up front, so you don't have to come around later and either recreate the AKS resource or have to use a tool to set that value, right? And then finally, advanced. I'll go to here, this blade, which just has one thing: enable secret store CSI driver. So that pretty much covers at a high level at least, the inventory of what is available out there in terms of when you go to create an AKS resource, what's available in the portal. And I even told you a few of the things that are not available in the portal but can be set through ARM templates in general. Is the very likely real world way that you'd want to do that. Okay, let me get back to the Azure portal now, where my AKS resource should be created at this point. So let's take a look at that. I put it all into this AKS demo RG right there. There's my AKS demo resource, and it looks to be properly created. Yes, good. All right, so we have now our AKS resource. Here are the steps that I need to do to deploy an application out to that AKS demo resource that we just created. First thing is I got to connect kubectl to the Kubernetes cluster. And to do that, I got to run AKS get dash credentials, and then dash and specify the dash resource dash group, specify the resource group name, and then dash name and specify the service name. So let's go ahead and do that right now. So I'm going to say AKS get dash credentials, and I'm going to say dash resource dash group, and then the resource group name, which I remember is AKS demo dash RG. And then I need the dash name and the service name, which is AKS demo. Let me just look very carefully and make sure I got all those bits right. Resource group name, that looks good. Yep. Okay. So that's step one, is you need to specify you need to connect kubectl to the service. So let's run that. Get credentials. I misspelled credentials. Get credentials. There we go. All right. A different AKS. Yeah. All right. I was testing this from this Ubuntu VM, so that's why I'm getting this. If I didn't have the file there already that it creates, then I wouldn't see that. But I'll just say it already exists in the kubectl. Overwrite. Yes, I want to overwrite what's already there. Yes, I want to overwrite everything that's already there. There we go. Okay. So that is the first step, to connect kubectl to the Kubernetes cluster. Second step then is from here, it's pretty much like what you're probably familiar with already from using kubectl to create deployments. I just need to say kubectl create deployment and specify the information about the deployment I want to create, the name of the deployment I want to create in the image. Then I'm going to expose that deployment through a service. Given the fact that we are working with a cloud-based service now where a load balancer is available, you might want to actually specify as the type load balancer there. Normally, there's a module I have in the Kubernetes class I teach on networking, where I talk about the 3 major service types available in Kubernetes: node port, load balancer, and cluster IP. I normally tell people, well, load balancer doesn't really benefit you a whole lot if you're working on-prem, unless you go out of your way to bring in something like Metal LB, right? But if you're up in a cloud service where you actually have a load balancer available, then it would make sense for you to go ahead and leverage that. And then finally, if you are going to specify through a YAML file your deployment details, then you would run standard thing, kubectl apply -f, right? But here is what I'm going to run in order for me, and I'll just do this all command line to make it simple, to create a node deployment based on that image that sits there in the ACR. So let me do a kubectl create deployment. I want to call it node-deployment, like what I have on the slides there. I want to set the, let's see, I'm going to set the image and I want to set -- image, and I got to get that image format exactly right. So I'm going to set -- image equal to, and just to make sure I don't mess it up, I'm going to go back to the ACR resource, copy the server name, login server name right up here, put that in, then /node demo :v1.0. That, I believe, is what I want. Let's go ahead and run that. Let's check to see if the deployment looks good first before we do anything else. So I'll do a kubectl git deployment, and I need to let me do this actually. We'll do a kubectl git pod. What I want to see is the pod in a status where it's failed or whether it's still creating. So I'm going to do kubectl git pod -w. Oh, it's running. Good. That's a good sign. It means at least it was able to find the image. Otherwise, we would have seen an error under the status column. And I'm just using this to check to make sure that it looks like the pod's good. Let's go back and run kubectl git deployment again and verify. Yes, that's exactly what I want to see. Under the ready column, it shows 1 of 1 there. So that is a good sign that at least it did find it and that we should be good. Okay, next up, we can actually try this out. Since this is running, since the deployment's running, I want to expose it through a service. So I'll do kubectl expose, and let's see, do I need to specify deployment? Kubectl expose deployment, yeah. Kubectl expose deployment, node -deployment. And I'm going to specify -- type equals load balancer, like that, all right? Oh, and I have to specify -- port. --port, and I'll specify just a port number of 80. So I'm basically going to run it just like what I have on the slide there, right? In fact, I'm going to do one more thing just as a best practice. I am going to specify a name flag of node service, because otherwise the name of the service is going to just default to the name of the deployment, which to me looks pretty ugly when you go to delete them or to look for them if the name of the service matches the name of the deployment. So I like to give the service its own name. All right, let's run that. Let's do kubectl git service just to check that the service is there, and it is. I'm going to run git service node service. Note that the external ISP is still pending, so I'm going to run it with the -w flag just so that oh, it's already there. That was quicker than I expected. So we have the external IP there. At this point, we can hit it. I should be able to just grab off that external IP and curl to it and see if we get anything back from there, and I'm not. Oh. Sometimes it takes a second or two from when even it says that it's available to where I can actually hit it. Let me check a couple of things. Yeah, let me come back around and try it again. The first time I hit it, it may take a few seconds, but I'm going to let that run in the background, and we'll come back to that in a moment. All right. In the meantime, we're going to go off and do another. In fact, let me check one other thing. Oh, it did. Wow, that was just a little slow to spin up initially, but it worked. I did prove to you that the AKS resource is there, and it is up and running, and I can hit it with this external IP address, and I'll hit it a couple of times. The subsequent times is faster. Remember, it's got to go and create a whole bunch of things internally in order for that service to actually service the very first request. But after that, it's very, very snappy, returns back to me right away. So that's an illustration of how to configure an AKS resource and then how to do the last set of steps, which are to create a deployment, to expose that deployment, and then to actually be able to hit it publicly through that external IP address like I'm doing right now. All right, let's see how I'm doing on time. Oh, good, doing very well on time. I have one other section of this that I want to show you, which is kind of like the culmination of everything, which is now that I have this AKS resource, I've got my ACR, I've got the AKS resource. The next level beyond this is for us to create a DevOps pipeline so that we can now have in a GitHub repo the set of source files that were used to create the image. And like I told you at the very beginning of this talk, the goal of all of this is for me to then set up a pipeline such that initially it will go ahead and build everything for me automatically. Basically, I just have to point it off to the repo that contains the same 3 source files that we started this demo with. And then after that resource has been created, we're going to verify that we can hit the server. And just like we did here, but instead of running kubectl where we are, we're going to rely upon the pipeline to build, instead of using kubectl commands and using curl to hit everything. Instead, we're going to rely upon the DevOps pipeline, point it off to the repo that contains the appropriate source files to create what's necessary in AKS for us. We're going to hit that. Then after that, we are going to change the actual source code. So I'm going to be able to come in and change the content here, so that rather than in the server.js file, it's saying hello world, we're going to change that string. Then we're going to automatically see when we do a commit to the GitHub repo that the build process through the pipeline automatically causes a rebuild to occur, a redeployment to occur, and then we can hit the exact same address and see the updated value that we specify in that send call in the source code. That's our goal between now and the end of this talk. All right. So let's make that happen. First, I want to just talk a bit about what DevOps in general is, just as a quick review. And to also make you aware of a fantastic talk about DevOps that I would advise you to have a look at. It's kind of old now. It's, you can see several years old. It was given in 2016, but still, at least the first part of this talk is well worth watching. And it was given by Donovan Brown at Microsoft, who was on the DevOps team. And this is a direct quote from the talk. He defines DevOps as the union of people, process, and products to enable continuous delivery of value to our end users. That's the definition that Donovan Brown at Microsoft gives for what DevOps is. Now, in particular, there's Azure DevOps, which provides developer services for allowing teams to plan work, for collaborating on code development, and for building and deploying applications. By the way, here's just a link right there that I put on the slide to the actual doc page right here with, it's from the Microsoft doc pages, but here's a link to where you can watch the talk itself. Donovan is a fantastic speaker. What makes the talk so cool is that he talks about what DevOps is in general, and then he shows what technology that was out there at the time, at least, where, and the talk is entitled From Zero to DevOps. You can see that in a little bit of this last bit of the URL here, where he starts with nothing and he has something up in DevOps, and ready to go into production basically by the end of the talk. Kind of similar to what I'm doing here, where I'm starting with nothing and I'm creating at the end of this a DevOps pipeline where we can take that simple Node.js application and get it up to where it's publicly accessible. And then even make it so that when changes to it occur, that automatically a rebuild occurs and a redeployment occurs. That's what we want to have happen. All right. Here are the prerequisites for what you will need. You will need a GitHub account that's used to host the application. You will need an Azure DevOps organization. And I put a link there for the details about setting up an Azure DevOps organization. You can create a new one or use an existing one. And you need, very importantly, and I'll demo to you and talk about this because it's one of the first big roadblocks you are likely to hit, permission to run pipelines, specifically a parallel job, right? And there is a way, by the way, you need to either purchase a parallel job or request a free tier. And again, I'm going to talk more about that coming up in this demo. I'll show you the out-of-the-box failure mode that you're going to see, and then how to solve that. All right. So let's first create a brand new DevOps project. And I have up, in fact, I'm going to close up some of these browser tabs that I opened previously just to avoid any confusion about where I am. Right here. Here is my personal Azure DevOps page where I have this organization, Arsumita 0274. I'm going to create a new project to get things kicked off. And I'm going to call this project, let's see, Node Demo Project. Let's call it that. Oops, Node Demo Project. Better yet, AKS Demo Project, because it's really going to be more of an AKS demo. So I'll call it AKS Demo Project. I'm going to make this public for the reason that I want you to see the failure mode that you get if you have not dealt with the parallelism issue. That's the only reason why I'm setting that to public right now, is just to be able to show you the way it's going to work out of the box if you want to be able to put something up publicly available. And then I'll talk about what you have to do in order to address the initial error that's going to occur. All right, notice there are some advanced settings down here for the version control you can specify from this dropdown Git or TFS, and for the work item process, any one of these. But I'm going to stay with the defaults. All right, I'm going to click Create to create the project. And this will take a second or two. And again, I don't like to sit there waiting for stuff to create, so I'm just taking you through the screenshots here that are the equivalent of what I'm going to create. Now, what's going to come up in a second is this page for the project itself, where I can create my first pipeline. But even before I create the pipeline, here's what I'm going to do. Now, I just want to tell you, I'm going to do something a little bit different from what's in the slides. The slides show you the screenshots for how to do this demo using a separate GitHub repo that you might already have created, right? Like if you're already working on a project, but maybe you're not using pipelines yet, you may have a GitHub repo created. You may want to use that as your source. I'm going to do this because this is an Azure talk to begin with. I'm going to do this all from within here, all from within Azure. In other words, I'm not going to be using a separate GitHub repo that I have. I will instead use the repos that are available through this project. So let me go ahead and configure that as one of the first preparatory steps to where we ultimately want to go with this. So here, under the project, on this icon for the repos, I'll just select files. And that will bring up here this page that shows me the address that I can use to clone the repo to my computer. And that's what I want to do at the very beginning. I'm going to copy this clone URL to the clipboard just to make things easier to see and also to make things faster for this demo. I'm going to use Git extensions, because what I'm going to do is clone that GitHub repo to my local machine. And I'm not going to work with the Ubuntu VM now, because on the Ubuntu VM, since I don't have a desktop there, I'm not going to be able to run a tool like Git extensions. Whereas if I'm working off my local machine, I can do that. So let me just get right into Git extensions. And like I said, it'll be so much faster than me having to type in all the commands and then making typing errors. So I'm going to just go this route. I'm going to choose clone repository and then specify that URL for the repository to clone that I just grabbed out of the portal a moment ago. All right, and I'm going to click clone. I need to specify a destination. I'm going to clone to C:// the root of my C drive, and it's going to create a subdirectory called AKS demo project, which is totally fine for it to create that on my local machine. So I'll click clone, and we're good. All right, that means I should have now. So it says, do I want to? Oh yes, I want to open it, and I should have, if I go to the Windows Explorer, a folder. Let me launch a new Explorer. A folder called under my C drive AKS demo. So let's verify that there, AKS demo project. There it is with the .git folder inside of there, which is exactly what I want. All right. Now what I'm going to do is I'm going to open up a new Visual Studio Code session and point it off to AKS demo project folder. And then I'm going to take all three of those files that we were using for this demo, and I'm going to stick them into that, and we're going to create a commit. Sorry. So I'm going to do a file open folder and specify here, select folder, and we are almost good to go as soon as this becomes responsive. And I'm just going to copy those three files from this Visual Studio Code session, which is using the Ubuntu VM. It's connected through SSH, through the SSH extension to the Ubuntu VM. I'm just going to recreate those three files, but within my local folder that the Git repo up in the Azure project's pointing to. All right, and this will just take a second. So I'm going to first put in server.js, and that is this content. I'll just copy the entire contents of the folder from the remote to this local location here. There we go. Okay, second one I need to do is I'll do Docker file. And then I also have to do the ignore one. And the package.json as well. Okay, so I want Docker, actually it's 4 files because the .docker ignore is the 4th file. Okay, so there's the Docker file. I need that one here. We have that. Oops, I did not want to change the name. I just want to explicitly call it Docker file with capital D. I want the package.json file, which is this file here. And I want its contents, because we all know this works because I proved that in the earlier parts of this demo. And then finally, I want the .docker ignore file. that, and that's just like 2 lines. But since I don't want to take the risk of mistyping anything, I'm going to explicitly go and copy that. And we have all 4 files now inside of this folder, which is the one that the Git repo is pointing to. Okay, next up, I should see, and I do under Git extensions, that there is a commit here ready to go. So I am going to stage all of those 4 files for a commit, and then specify Node.js hello world demo is what I'll call that initial commit, and I'll do a commit and push. So these files are all available in the repo right out of the gate before we create the pipeline. Okay. Okay, again, I don't like to sit idly waiting, so I'm going to go back to here to my project, and let's create the pipeline right now. So I'll choose pipeline. Let me just verify. Okay, I should say okay, because I do want these files pushed up there initially. And there we go. Okay, good. I see that I have a local master branch, and I have the remote one, and the 2 are in sync, which is exactly what I'm hoping to see there. Okay, cool. Let's create a pipeline. And now when you create the pipeline, ask you where your code is. Again, I'm going to do something a little bit different in the slide. Since I'm not working with a separate GitHub repo, I'm going to work with the one that's part of this project. I'm going to choose Azure Repos Git there. Right? And then I'll choose the AKS demo project for the repository. Here, I'm going to choose deploy to Azure Kubernetes service. Note I'm not choosing Node.js. I'm going to choose deploy to Azure Kubernetes service because I really want this to be deployed to AKS, since that's what those files were intended for. All right, what it'll do is it'll load up my subscription. It'll populate it with a drop down that shows my subscription. Then after that, I should be able to actually see the ACR resource that I created earlier when I click continue. So right here under the cluster, that's a good sign. So the exact same AKS demo cluster that I created earlier shows up in the drop down here. Then I'm going to select for the namespace existing, that's fine. I'll pull this down. I will choose default. And then for container registry, there's my registry that the AKS resource was linked to. And this is all good. This is exactly what I want, except for one thing. I want the service port to be port 80 instead of 8080, which they default to. All right. So this is what I need for deploying to my Azure Kubernetes service. I'm going to validate and configure. All right. And then basically, now that I have the source files there, I have the pipeline pointed off to that repo. Here's the YAML file that's being created. Now, because it's creating a YAML file, in fact, let me go ahead and I'm going to kick this off by doing a save and run, but you can take a look at the YAML file that's created here in order to configure the bits that are needed for the pipeline. That's what you're looking at, all right? When I do a save and run, though, this is going to fail. And I wanted it to fail because I wanted to tell you about that parallelism problem you're going to run into out of the box, and then I'll make it work. All right. So I'm going to choose save and run and click the button. That is actually going to start to run the steps of the pipeline to take, and here you see it right here, the build stage and the deploy stage. So it's going to take those files that are in the repo, use them to do a build, and in a second, and then, in fact, there's the error. There's the exact error that I was telling you about. You see it fail. You can, by the way, watch by looking at this build stage. You can watch the details of the build, exactly what step it's on. But it may be a little bit hard for you guys to see this on a screen share, but it says no hosted parallelism has been purchased or granted. To request a free parallelism grant, please fill in the following and then give you additional information. Let me get back to my slides for a moment. So this is just a set of steps that I went through. This is, again, the slides talk about how to do this with a separate GitHub repo, but I'm using the one that's up in the project. And this is what you have to do, which is, well, that's what you're ultimately going to have to do. But let me get to here. If you're using a separate GitHub repo, by the way, you're going to have to authorize the pipelines to have access. And then you select your repository. and then approve and install the Azure pipelines. This is if you're doing it again with a separate GitHub repo. Because I'm doing this all inside of the same project, I didn't have to do that. All right, and then you choose deploy to Azure Kubernetes service. This is exactly what I did a moment ago. Specify all the right settings, pointing it off to the AKS resource I created earlier with the right container registry specified in the right namespace. Review the pipeline and save and run, and then you're going to get this parallelism error that we're hitting. In fact, you can see the parallelism error a little more easily if you go underneath pipelines here and just look at this page right there. When I click, you're able to actually view it a little bit different way right there. No hosted parallelism has been purchased or granted. So let me tell you what's going on with that parallelism error. Azure Pipelines offers free CI/CD, up to 1,800 free minutes per month, and 10 parallel jobs to open source projects. However, new organizations do not necessarily get 1,800 free minutes. If you want to read about why Microsoft restricts this, you can go to this blog page that I linked on the slide there that talks about this entire issue and why they made the changes they did. Notice this is dated March 16th of last year. Basically, the short story of the reason why is people were abusing it. Right? People are using this to do things like send out spam. And so Microsoft wanted to restrict people from using it for that purpose, or for example, mining Bitcoin. So they made it so you have to go through this application process. They say that to get the approval takes about 72 hours. From my experience, it only took about less than a day in practice. But again, that's anecdotal. It may take up to that long for all I know. But you should be aware you're going to have to go to here, which is this website that I linked. Make a parallelism request. You have to fill this in, and then you wait for Microsoft to come back to you and grant parallelism to you, and then after that, you will be able to successfully be able to do the steps that we were trying to do. One thing I can do though, given that this particular setup is not granted for parallelism, I have it in one of my other setups, but not in this one, kind of on purpose because I wanted to show you the failure mode. If I change the access to private rather than public for the repo, then that problem will go away, right? Then I'm able to do it without the parallelism grant. So I'm going to go to the settings here. Let's see, I think it's under, where am I? Policies. On the settings, I want to change this. I'm in the wrong place. I want to change the setting to public rather than private for the entire project. Actually, I need to be on overview. There we are. So instead of public for the visibility, I want to choose private and then choose save. And then I'll rerun the pipeline, and then we should be good, even without the parallelism grant. All right. So let's go back to pipelines. I will now choose all like this. Choose this one. Oh, I want to choose a run. Run pipeline. That's what I want right there. Okay. So we'll retry it with private instead of public, where I don't have the same requirement on the parallelism grant. And then we'll just verify. This will take a few minutes, but we'll verify that at least it kicks off and gets farther than it got last time when I had it set to public without the parallelism grant. So again, you can watch the build process unfold as we're doing right here, looking at the build stage in detail. You can expand this out, and already I can see it got farther. Oh, build and push. Is it through that? Post job check. Oh yeah, it's already running. Or oh, this is a dreaded error. This is a different error. Agent is already running and is already completed. What didn't it like here? Finishing build and push to container registry. Error response from daemon. Unknown instruction. Docker file parse. Oh, did I mess up the Docker file somehow? Let's double check. Docker file there. Oh, I have an extra character in the Docker file. All right, well, at least it was doing the right thing. In fact, I can use this as an unintentional illustration of exactly what I was going to show you, which is the pipeline will automatically rerun when I do a new commit. All right. So you see that last job failed because I actually introduced an extra character accidentally, but that's okay. We can use that to illustrate what I want you to see in the demo, which is when I create a new commit on the repo with the change, because here's what I had a moment ago. I had this extra S character in there. So I take that character out. When I save it and recommit, then automatically the build process should kick off again. All right, so a couple things I got to do though. On this side, you see there's a one change to the file I made. I'm going to have to do a pull first, because remember there's a YAML file that got emitted from when we set up the pipeline. So before I can do the push successfully, I'm going to have to do a pull just to get things in sync because of those additional files added in when I created the pipeline. So I'm going to pull from the remote, and then I'm going to push the change of that one file, that messed up Docker file where I accidentally added that one character in. Okay, so now we should be in sync. I'll go do a commit, and I'll say stage and correct error in Docker file, like that. Do a commit and push. All right, and here's what I want to do too. I'll go back to the pipeline. I'll just leave this up like this and see, hopefully this kicks off automatically when I do the commit. So we shall see. All right, we'll do okay there. That commit is been done, and let's see if the pipeline gets triggered to run, which it should when there's an updated change made. Let's update on the pipelines there. Correct. See, already it's showing up here when I refresh. Correct error in Docker file, and it's starting to run. I can see that it's starting to run. Let's again view the stages and see if it gets through the stages this time. So it's in the process of running. This is the build and push where it failed last time. So you can monitor the progress if you want to actually see what's going on as it runs. And this is where it died last time with that extra character in there. You see how I didn't even have to kick off the build process again. All I did was I just did a new commit out to the repo. Automatically, this pipeline is seeing that there's a new commit there, automatically runs the build stage, and hopefully it gets all the way through this. In fact, it got farther than it did last time, so I think we're good at least on correcting the error that was there. And then it'll publish and do the checkout and then do the deployment. And then once that's all done, we were going to hit the actual service that's being created and verify that we can see Hello World in the browser when we do. That's what we're looking for. All right, let me get back to the slide again so I don't have to sit there idly waiting, but this is the story of parallelism, and you saw the type of error that you get out of the box if you try to create a public project and you have not yet applied for the parallelism grant. All right, ultimately, this is what I'm going to do when this finishes. I'm going to click on the environment tab in the project. I'm then going to go over to here, which is under the resources, I will find that default namespace. And then I'll be able to click on the services tab, find the external IP and hit that external IP, and I should see Hello World when I do. That's what we're looking for. All right, we're getting close. We're at the post job checkout part. And usually too, what I've noticed is that, yeah, it's a little bit of an odd thing. This for some reason stays grayed even though it's done. Even though the finalized job part, and you can see it's done there, but it jumps to deploy, and the deploy is looking good because I'm seeing green check marks. If we get past this last one, which is deploy to Kubernetes, then we're done. And the whole build process will have completed, and then I'll be able to actually like do the steps that you saw on the last couple of slides and be able to hit it. There we go, finishing deploy. That is all looking good. Let's go over to environments under pipelines. Do the exact same thing that I showed you in the slides. Hit that AKS demo project environment. There's exactly what you saw in the screenshot. Default, I'll click on that. And then under services, click there. AKS demo project is the one I want to look at. And external IP, I will grab that, copy that off to here and hit it and see if I get Hello World, and I do. So that's an example of how I don't even have to really create the Kubernetes deployment manually at all. All I had to do there, number one, set up the project. Number two, use either a GitHub repo I already have, and you can see from the screenshots on the slides how to configure it that way, or to use the GitHub repo that's part of the project we're working with, and put all the source files into there. And then from there, just walk through the steps when you create the pipeline of pointing it off to all the right places, and everything will kick off basically automatically. Now, this is the very last culmination of everything in this talk, and then we're all done. And it's what I said I was going to do at the beginning of the talk, so we're going to do it right now. And I think you have a pretty good idea it's going to work because you saw that correction to the mistake I made in the Docker file by adding that one character. You saw that that worked. But I always like to show this because it's kind of cool. I'm going to put in here a good afternoon, or depending on where you are, maybe good morning still. I'm on the West Coast, so it's still morning for me, but I'll change that to good afternoon. I'm going to save that, right? So we're changing the source code now. This would simulate us working with a Kubernetes deployment with Azure pipelines. I make a change to my source files. Now, note I'm not going to have to run kubectl or at all. I'm not going to have to go back to anything on the command line. All I'm going to have to do is, well, unless you're running git from the command line, in which case you will have to use the command line for that, but do a new commit. And this is why I'm using the tool, because it's easier and faster for me to do it this way. I'm less error prone. And then I'm going to say change message to good afternoon on the commit. All right, commit and push. And once again, I'm going to just configure this so you can see it'll get kicked off automatically. Back to pipelines. And I will commit and push. And then it'll automatically go through and restart a new run with a rebuild and a redeployment with the change. And what we expect to see after that has all finished is that good afternoon string rendered in the browser instead of hello world, which is what we had before. First, let me just verify that number one, that commit takes, and number two, that if I come into here and refresh and take a look at the pipeline, that is getting, yeah, there we go, change message to good afternoon. It sees the last run there, and we should verify at least that it's being kicked off. And it is, it's in the build stage right now. So that's looking good. And when this completes, we will verify as the very last thing, which is what I promised to do at the very beginning of this talk, which is that that change is now up in production after this job finishes running. Again, since I don't like to sit there and it's going to take a minute or so to finish up, let me do a couple of last things. This is just the change that I made to the source code. And I did a commit. Here is the pipeline being triggered, screenshot of the pipeline being triggered automatically to rerun with that update. And then we're going to retest the deployment when that finishes. Let me go ahead and wrap this up. So here is the summary of what we talked about. We talked about how Azure provides Docker and Kubernetes infrastructure that's managed, serverless, and relieves the developer and admin from worrying about managing the VMs and the operational tasks. The three major resources that are available in Azure for working with Docker and Kubernetes are the ACR, the Azure Container Registry, which is a private container registry that supports Docker and the OCI, the Open Container Initiative. The ACI, which is an Azure environment for running your Docker containers, and AKS, which is a full hosted Kubernetes service with a built-in load balancer. And then we also talked about in the second half of this talk how Azure provides, as you saw, an infrastructure for creating a CI/CD pipeline for AKS. And you start by creating an Azure DevOps project. You can either work with an existing GitHub repo or use the GitHub repo that's part of that project. Create a pipeline, configure that to use GitHub as your source for the code, configure the ACR as your repository, and configure to deploy to AKS. Then you can initially run the pipeline if you would like, or you can have it get triggered automatically by just doing a new commit into the pipeline. But in any case, once there's a new commit available, it will automatically go and rerun the pipeline, and then you can test the deployment. And this infrastructure, or some equivalent, is the best practice infrastructure to use for real-world deployment. And in particular, if you're going to do real-world AKS deployment, what I'm demoing to you here is what you want to look at using. All right, fortunately, that was pretty quick. It's done. Let's just verify. This is the culmination of everything in this talk that worked. So we're going to go again back to environments. Oh, I have left it up. All I have to do is refresh right here. So it should be the same external IP address. So I'm going to refresh. When I do, it shows good afternoon. So we got the change. Okay. Any questions about anything? I have 15 minutes left, so I'm happy to hang around and answer any questions that you might have. And Brant, if you're on, if you want to do a little bit of an intro, feel free.
And Brant wasn't able to rejoin us.
Oh, okay.
But Zach had a question.
Okay.
Is this, and it's early, it was almost an hour ago. So is this how you would route the pods DNS to the public IP address of a Kubernetes cluster?
Yeah, if you wanted to do stuff like that, then what I talked about in the configuration of you're talking about routing. Can you repeat the question? Sorry, I want to make sure I understand.
Oh, sorry. Is this how you would route a pod's DNS to a public IP address of a Kubernetes cluster?
Route the pod's IP address to a public.
Okay, Zach said it was during the private DNS zone part.
Okay. That's an important context that I need to know about. It is, yes, if you that private DNS zone bit is what you would have to be concerned with. That, in conjunction with what you saw in that networking blade, is all stuff that you would have to very carefully configure, depending upon how you want, whether you wanted the pods to have explicitly available IP addresses. Then yes, that is a way that you could make that happen. Any others?
Nope, Zach said that was good.
Okay.
Nope, if anybody else has any questions, please put them in the chat window and we can take care of it. Whoops. Regarding what the customer has to maintain, you mentioned nodes. Are we responsible for OS updates?
For OS level update, no, because remember, when you're dealing with containers, the whole container infrastructure is independent of the OS. That's really a point behind Docker and Kubernetes in the first place. So no, you're not going to have to worry about OS updates at all. In fact, you're really running inside of a VM, and at a very low level, you're running inside of a VM, and it's the VM that would have to worry about the internal VM that's maintained by Microsoft in the case of Azure, that where the worry about the updates to the OS would be where the concern would be. But that's outside of your control. What you're concerned with is creating the containers and then deploying them in the way that I showed. So no,
okay.
OS.
Adrian said, I meant the node VM.
The node.
So he said, regarding what the customer has, it's flipping on me, sorry. Sorry, Adrian. Hold on, okay, here we go. Regarding what the customer has to maintain, you mentioned nodes. Are we responsible for OS updates? And then he said, I meant node VM.
Node VM. Is this something specific you're talking about? Is it possible to open up the mic?
No, I don't think we're able to do that. Adrian, can you give me a little bit more detail on that one? And Sai has a question. What is Kubernetes cluster with Azure Arc?
Kubernetes cluster with Azure Arc. Is just a what is question?
Yep.
Okay. Let me point you to the appropriate place where I can. Let's see. Here we go. One second. I'm in the wrong browser, so let me do this. Goodness. Do I have Chrome? I do not even have Chrome running. Okay. Give me 1 second and I will point you to the appropriate spot where you can get all the information. Here we go. There. This is the best place to go and look at for the details of, I assume this is what he's talking about, Azure Arc enabled Kubernetes that allows you to attach and configure Kubernetes clusters running anywhere. And you can connect your clusters running on other public cloud providers such as GCP or AWS, or clusters running on your on-prem data center. And for more information about it, this is the place to go. But that's the short answer to the question of what it is. There's a dedicated Microsoft doc page that I wanted to show you that talks about that.
Okay, so I said that was his question.
Yep.
And Srini's asking, is it possible to share your Azure pipeline YAML file as an example?
Yeah. Although my recommendation would be that you probably want to just go and configure from scratch yourself, but I'm happy to share that. Let's see, can I put stuff into the chat for this and then have everybody be able to put it down out of there? Is
I
that
believe
possible?
you can. Yep.
Okay.
And just
Here.
send to the entire audience.
Okay. So I will, let me see here. That is the chat. Hopefully there's no size restriction on the message, but I'm gonna put the message there and see if it made it in. Yeah, okay. And I think, yeah, so that is my entire YAML file. Like I said though, my suggestion would be create your own pipe, replicate basically what I did here and start from your own, because the YAML file is going to be created for you automatically anyway, right? And you probably want one that you start from that is where all the settings are configured to your particular environment going in. But in any case, yeah, that's the YAML file that, keep in mind, I didn't type that in. That was all generated for me by the tooling.
Okay. Anybody else has any questions? Tyler is asking, how would you modify the pipeline to update the container tag each time? Something like each push increments the version or tags it's based on the hash of the commit.
Oh, so you want to, okay, so let's see. So each time
How would you modify the pipeline to update the container tag each time?
Yeah, let me see. I think you can do that. Let me check something. So, given that yeah, I think I remember doing something like this once. You have to do it through that pipeline's YAML. Speaking of the YAML file, I believe you need to look to do it there because that's where you have some control over the way that the build is done, the build of the image is done. I don't recall off the top of my head the exact set of steps, but I can probably point you to a resource. Let's see. Let me see if I can find it. And here we go. This is, I think, what I'm looking for here. Let's see. Oh, and I know exactly what I'm looking for too. Azure Pipelines YAML. Okay. Because I believe I do a setting there. Here, let's see. See if I can find it. It wasn't where I thought it was. I'm still looking for the spot in the docs for where they talk about. Here we go. Or this is probably what I want. I think this is what I want. Let's see. Yeah, here we go. So this is the website I think I was looking for, where this question is asked on Stack Overflow. And let's see, sample scenario. Yeah, so you can look through here, but I think this one does show. Yeah, here under tags, parameters.tag is what he's using. And it's definitely going to be in the YAML file. You gotta look to do this in the Azure Pipelines YAML file. You can specify as an input's a tag input, and then you can specify that tag in turn when you go to have it create the image. So I'll see if I can find a little bit better doc page that mentions it, but basically, yeah, it would be done through the YAML file. In fact, let me see if the documentation on that YAML file might have an indication of that. For this, we probably just want the references and see if there's a specific spot in the references for the tag. Maybe not tags. No, they don't appear to reference anything there, but you might want to at least start from that Stack Overflow discussion that I showed, because that did have a little bit of information. And also, let's see, Oh, this is just recommended best practices for tagging. But yeah, it would be through a setting in the YAML file, but I'd have to do a little more research to find the exact setting that you would need to tweak. But you can at least use that as a starting point for where to go and look.
Okay. Let me know if that helps, Tyler. John has a question. Is there a way for Azure or Kubernetes to monitor the process and kill DDoS runaway processes and redeploy?
So you want to be able to, yeah, if you're getting like some type of, if you're getting massively hit and you want to, you know, if you're getting like a DDoS attack and you're looking to, you know, is the question to redeploy or is the question to just like restart? Can you repeat the question just so I know precisely?
He said, is there a way for Azure or Kubernetes to monitor the processes and kill DDoS runaway processes and redeploy?
Well, one thing you could do, you could set up a, if it's one thing you could do, you could go and just install a monitoring process, right? Because, you know, you could just run that, and that keeps tabs on what's going on with your Kubernetes deployment. That's one way that I could think of, right? Because you can just containerize a separate process that goes and, you know, monitors what's going on with the Azure process. Let me see if there's an established way to do that, though. There may be something that is built in that might, let's see. Yeah, in fact, you may want to have a look at this too. Because Microsoft does have Azure DDoS protection from DDoS. And let me see if, because this sounds like the kind of thing that you probably would not want to try to do on your own if possible. So this helps protect your apps and resources with a profile automatically tuned to your expected traffic volume, defend against even the most sophisticated. Yeah, this is what I would look to do first before even trying to do anything on my own, because Microsoft actually has, you know, something in Azure up for DDoS protection. So start from that, see if that, you know, either does what you want it to do, or you can turn it into something that is configured the way that you want, so that it will protect you against DDoS. That's what I personally would recommend. Short of that, the last resort would be to write your own monitoring thing. But given that, you know, that is a pretty hefty task, and DDoS protection is something common enough, I would start with, you know, what's already up there in Azure.
Okay, so John is saying, I guess this is more of a generic Azure environment question. Yes, this is what I was wondering, the Azure DDoS's protection. Okay. So Sai is asking, how would you roll back a deployment?
Roll back a deployment. That is all done. The best way to do that is through Helm, is what I would suggest. It can be done one of two ways. You can either do the rollback from just straight Kubernetes, but Helm has really good rollback facilities. So there's I don't know if you're working with Helm currently, but Helm is right here. This is the doc page on Helm rollback. And I mentioned Helm early on in this talk. If you're not using Helm, my recommendation is you should be. Deployments are much better done through Helm, and rollout and rollback is much better done through Helm. One of the things I like about Helm rollback is it maintains a history, so you can see the entire history of all the rollouts and rollbacks, and you can roll back, you can undo the rollback. I mean, it's a lot more flexible than what's already there in Kubernetes. So this is not anything, by the way, unique to AKS. This is straight Kubernetes Helm, but rollback is what you want to know about.
And isn't that funny? Adrian is just asking, how does Helm tie in with pipelines, if at all? Sorry if it was covered, I just had to jump in.
So. Oh yeah, keep in mind, a pipeline, you're just putting in a set of commands that you want executed. So if you you can make the Azure pipelines work in conjunction with Helm just by specifying the appropriate commands in that YAML file, the Azure pipelines YAML file, right? So depending on what Helm commands you want to execute, you could specify them right in that YAML file.
All right, I think that might be the last of the questions.
All right, cool. a lot, guys, for asking good questions.
All right, thanks everybody. And we'll be sending out the recording probably early next week. We'll get it over to you.
Okay, cool.
All right, thanks.